I thought I could do something just before while Dennis is not here, because I mentioned, I brought up this problem specifically about how to rewrite the triangulation, and then it led to all the other issues and so on. Because I'm writing with Thiago, that anthropologist, this text for like 2 years now almost, on like the mode A approach to things, and it's like the third run that I try of making it better, because originally it was like total mess. We had no idea what we're talking about, but then writing the social atoms and social worlds text, we got to talk a bit more about, okay, what should we, how far do we need to go with explaining this technically? What is the correct approach to explaining this technically, and so on. So I managed to perfect it a bit, but now other problems appeared. Like, I think I can explain more or less clearly, though the conversation on our group already changed a bit how I would do it, or at least raised an issue. Like, I can explain a bit better in a way that's not just like the original way we would explain this was, intuitionistic logic has many values, classical logic has 2 values, and paraconsistency has 3 values. But we've grown as people since then, and now we know that that's total bullshit, and I cannot just do the little thing I used to do, remember, where I would like add to the ID function a different set of possible values just to clarify which logic it is. Because there's actually no, there is no different values to them. Like, it would be good to discuss if this is the case, but it looks like most texts, when they want to write it down, like, so you are in intuitionistic space, or you are in a paraconsistent topos, you are in a Boolean one. What they do is to say, so the algebra that goes with this classifier thingy, with what we call a transcendental. Let me see if Dennis is trying. Yeah, I think it's this. The algebra that goes with this thing, it has like the questions you need to answer are: does it have a maximum? Does it have a minimum? Does it have and then it gets a bit fuzzy. Usually the way it's written, like in those texts on paraconsistency, they say, well, you have algebra which has a maximum value which stands in for true, right? If you're talking semantics, a minimal value that stands in for false, and a complement operator. And then they define, like, if it's a pseudo complement which has this structure, it will be a paraconsistent one. If it has the complement structure that is like this and that, then it's intuitionistic. So it's at the level of the operator inside of the transcendental that they distinguish it, right? Which is not what we were doing. So this is the first kind of lesson, but then it said that it's not clear if we should strive to have, I mean, I think that's what I understood from the conversation. The first thing is there should be a way of distinguishing the transcendentals based on the complement operator inside that's part of that algebra, right? You're describing like what type of value and you say it's an ordered, a distributive lattice, which already implies it has a maximum, that it has an order structure. You say it's a distributed lattice with a maximum and a minimum. Then you can interpret it as false, true, or total set and null set or whatever. And you describe the operator that tells you how you split parts of this lattice, right? That's the place where these things get distinguished. And then you can say it's a pseudo complement, this constructive complement that gives you the intuitionistic negation, or it can be a classic logic, right? Which actually in my head kind of clarifies why you can have many valued classic logics, because let's say you have a bunch of values in a lattice, but you can still prove that once you take the envelope of some values, the negation of that envelope covers everything in the lattice. So you have a perfect kind of complement. Well, you do have many values. It's more or less, right? But once you decide on a synthesis on those values, you can still get the perfect complement for it, right? So you could get an intuition of how you can have many values and classical, which is something Dennis mentioned to us like in the last couple of months, and it just felt so like, okay, I never thought about that before.
What was the last thing?
I mean, yeah, the idea that here, let me share my screen. So this is how far I went. This is what I understand from the conversation before we get to the problem. So is that like most of these texts, as far as I found, you usually, though using a bit of our own notation, but usually they will say something like, yeah, you have a topos E, like this is the Mortensen way. You have a topos E and you want to create the complement topos. The way you do this is by defining this algebra, which it is a distributed lattice, which means it has a partial, or it has an ordering operation. It has a maximum, it has a minimum, and it has this weird thing. Everyone writes a different symbol, right? I like the way that that he writes. Actually, it's even better. He writes just an inverse negation. Negation is usually like this, right? He just writes it like this. And then he defines it. So, and then he shows that, well, everything will be consistent. And then he goes through all the like symmetry, transitivity, all the things that blah, 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 here on the topos. And he shows that they find like this inverted. If you use this and you define this appropriately, you get the kind of dual of it, right? We do know, I add an asterisk here, that a lot of mathematicians consider this dualism the weakest type of dualism. So if this is a Heiting algebra, this is a co-Heiting algebra in a sense that is not that strong, because in a certain sense it's indistinguishable from taking the lattice that exists here like this, right? And then I don't know, we can add some symbol for the let's do like this for the intuitionistic complement. It is kind of just the same thing relabeled. So they say, yeah, you're just looking at it from the other side, but you don't get just the structure itself. You don't get that many non-trivial things. It doesn't look like as different from, as you know, union and intersection, product and co-product, which are things that can build totally different structures. So I think this is what Matteo was a bit annoyed, and other people also mentioned. And if you open the Mortensen book, he says it himself. For example, I just saw this. He says, I think it's one of the last things.
Just a parenthesis. Okay, I was reading a bit of the beginning of Mortensen, and so I mean, there's this initial definition, right, it's a distributive lattice, and there's a maximum, minima, and a complement operation. Then there is some sort of like equation that relates how the operator, the complement relates to the union and the meet and join of the lattice, right?
Yeah.
There's some like how they behave, and these guarantees and that's, I think, what makes it a paraconsistent algebra is that, so this leads to some like properties that can be derived from these axioms which relate meets, joins, and the complement and the inequality, such that you get the excluded middle it obtains, and also that in general A and in the sense the meat, I think the meat and the complement of A are not in general the minimum. So you get like the sort of properties that once you interpret in a logical way, so there's also like so there's the first step, which is this definition. And the second step, you get the properties of that become excluded middle and the negation of the law of contradiction. And you also get some like negation of negation properties. And that's once you interpret this distributed lattice in a logical way, right? Once you associate like the meets and joins to like ends and logicals, disjunction and conjunction and so on, and the maximum is true and so on, right? So there's this, just so I understand how, so the algebra is just like this sort of like empty, this lattice, and then it gets, by defining this complement in such way, you get the logical properties once this lattice is interpreted in a logical way. Is that right?
Yeah, I have the same question as you, because the way I understood this is that, let's say, if you just take these three first defining features of these structures, they're the same. And then you have the fourth, which is just, as you said, they're defined on different things. So one will say, like, as far as I understand, it's kind of like the complement for, so yeah, the reverse, right? The complement in a intuitionistic framing. So P is such that yeah, it's the union of every Q, the union of every Q such that the conjunction of P and Q is 0. Right? So you find, let's say you have, so here on the top one, let's say you have some value, right? P, you find everything that has no conjunction with P, and then you take the union of all of that. That will be the highest value of everything that has the minimal conjunction with you, right? So it will, like, I think this is a small too small a lattice for something not to have. So yeah, R and S, Q has conjunction with P here, right? So that already wouldn't be the value. So yeah, it's not a good example, but it would turn out,
I think T,
as if
maybe T, isn't T
right here like this, right? So you have something like this envelope, everything that has conjunction, and then you take this thing here, which is the highest value of everything that has no conjunction, something like this, right?
Yeah.
And but then you define differently the other negation. You define the complement of P, the paraconsistent complement or the pseudo complement, as the conjunction of every Q such that P union Q is great. No. Yeah. It's the largest lowest bound what did I do wrong here? Yeah, the largest lowest bound of everything that has no union with P. I think that's it.
I think part of it is you need capital M above, right? And then
Yeah, there's something
M,
weird here because I think you need to invert
in the first one, right? So
here's minimal, right?
Yeah, I think down below I would guess.
Yeah, I
it's-
used 0 and M, but M here was minimal. Like it's smallest,
Yeah, but
smallest
I
than
think
0. Yeah, it's
But
not.
below-
It's totally disjunct.
but below isn't it the maximum maybe?
Yeah. You're right. Here is actually like this. Yeah, for some reason I got this.
That's okay. I misread.
Sorry, let me just get here from a paper. Here, in the conciliations paper, they define it. It's the yeah, because this is this thing here, right? The upper one. This is ultimately what's called a locale. This thing here is what they call a global. In that paper, I'm just trying to see where they define.
So can we look at those almost as like the minimal structure of like the zooming? Like a locale is like the zooming in, right?
Find where
Zooming
it
out.
is. So yeah, it's not a zooming. This is the weird thing. It's yeah. So I just want to make sure I'm not writing this wrong. Where they say.
One of the things that was helpful in Raziak's discussion was like the idea that topology is closely linked to approximations and kind of like this fitting idea. So wouldn't this be like the fitting, or
Yeah,
is
but
this
see. Yeah, I don't know what you mean by that. Just trying to just 1 second, just so I can get the right how they invert the thing, because either you say that this operator, it's the conjunction yeah, I think the place where you can see this the best is actually not even here. Like the operator that I learned how to write is this. Just 1 second. This is the comparison, is that you say that P implies Q in an intuitionistic thing is the same as the value of this is the same as the envelope. Sorry, let's go back. The union, right? Of every X such that the conjunction of P and X is smaller or equal to Q. So the more stuff there is such that the envelope of the thing with P, with the premise, is equal to Q, the higher the value of this. So to the point that the tautology is always maximal, because if this is P, the conjunction of P and P, if Q is P, the set of everything whose conjunction is equal or smaller to Q, which is P, will be P itself. So it's maximal, but everything and then you have here this is how they write the dual of this, which is the what they call pseudo difference, which is, then you can see how it applies. They say it's the conjunction of every X such that the union of P and X is bigger than Q. Just so you can see that they invert all the operators, including greater than, conjunction. So it's pretty much the same, but it's reflected, right? So you get the same thing when you go to the negation. The reverse of P equals the union of every Q such that the conjunction of P and Q is smaller or equal to 0, which leads us to say that the pseudo complement of P, again, inverting everything, which is weird, is to say it's the intersection of every X, what is here? Sorry, every Q. Every Q, yeah, such that the union of P and Q, then we need to invert as well, is greater than I don't know if it's 0 or the maximum. It cannot be greater than the maximum. So, sorry, just 1 second. This is the minimum. Either this, I don't know if we invert this to write the maximum, so that's a question. In Mortensen, I'm not sure if it's made explicit. Let me check.
Can you flip the first?
Sorry?
Can you flip it around so it's intersection at the bottom? You're leading.
It's wrong, right?
Yeah, it should be intersecting, right?
Yeah, it should be. Yeah, exactly right.
So
Just trying to find
one way to frame the question, I think, then would be like, what is the right context in which the difference between these two is non-trivial, right? That's what we're trying to figure out.
I think first of all, we're trying to figure out if we're defining this properly, right? Dennis is joining now. Just see if I can open it for him. Oh, there you go.
Hey guys, sorry I'm late.
Hey, Dennis.
Yeah, I'm just trying to find this here. Yeah, the way that they define.
We're working on consolidating our definitions. And we have an open question on the very bottom one, if union PQ is greater than void or maximum, if you have a insight into that.
Yeah, the reason why I was writing this is just because, right, we were seeing, for example, from Mortensen, that the way that he presents it and the way that the reason why at the end he adds this proviso, which is like, raising the question of whether there is a construction internal to Topos theory rather than dualizing outside, which also yields a paraconsistent logic. So they are in doubt because they know it's kind of external. And that's what Matteo was complaining, saying that this is too superficial. And it's a critique you find in some of the texts trying to present this paraconsistent stuff. They say, we know that this is just a labeling. So why is it that dualizing here looks like you're just relabeling things rather than, and I think that it has to do with the fact that you operate this at such a late stage. You're not just inverting arrows and getting the co-construction, right? You have the arrows, they go the same way, and then you say, keep them the same way, but let's label them something else. I think that's why they call it external, perhaps.
But yeah, I don't really get this argument because like it's just you motivated from somewhere and you got to use it, and then you realize that you dualize and you get another structure. And again, as we talk, like they have different semantics, right? They have different logics, so their applications are different. So I don't really get, like, there's no primacy. It's just like a bit historical, a bit like what was useful. but like there's in Mortensen he says that Lovere said, oh, maybe this like paraconsistent topos can be used for thermodynamics. There's also like Rosier discusses why like you could make the case that like that the closed set topos are legitimate. I mean, there's no like primacy, right? They're to the very least both are like on the same level. And again, they're really different once you get to the semantics, because then you get different logics. So it's
Yeah, I'm not
just,
sure what you.
I don't know.
Yeah, I see what you mean. But, you know, I have the impression that generally that's not how, for example, people who have argued in favor are usually logicians. And for logicians, semantics and syntax are very different things. But for category theorists, they are not. I mean, I was reading today the link that Dennis sent that John Baez is talking about first order logic and category theory. And the first thing he says is, we category theorists treat semantics and syntax as the same part of the same world. There's no big disjunction. So when you say, yeah, we have something static and we're changing the semantics, those are different things. I think that it's not organic.
But what
enough.
about the topology? Like people who do shift theory are sensitive to defining them with open sets, right? Because that leads to like different data structures. So there is like a correlation between all that. So like,
Yeah,
this-
I don't know. Yeah, I tend to agree with you, man. Like for me, it sounds like it should be recognized as enough of a non-trivial thing to be called a dual. But the fact that Mortensen wrote it himself there in that note I added here, that is not intrinsic. There must be a recognizable distinction in that sense, right? And I mean, if you look at this thing here, like this is how they introduce the paraconsistent algebra, right? The Breuer algebra. Like their definition is, again, see the thing we spoke of, it starts exactly the same, right? Distributive lattices with a maximal element, minimal element, and then a complement operator. And then they define how that complement, these are the further properties, and they're all on the complement, how the complement operator behaves, right? And then they conclude in general, this is the case. So they are very, let's say, I'm not sure. It sounds to me that they're very high order definitions of things. Like it doesn't, you know, you need the operator defined, introduced algebraically, like you have this space and you have this operator operating on the space, you know, like as a primary thing to distinguish. It's not like, you know, it follows naturally from how the morphisms are structured and associativity and blah, 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 that you will get a weird logic here. And perhaps that's what they call non-intrinsic. I'm not sure.
Sorry, I missed the beginning. So what is the question we're trying to answer?
Yeah, first of all, I think we were trying to go over first this. Renz, you're adding that on. Are you looking in your own screen? Do you mind if I move, or does it get in the way?
oh yeah, you can move. I'm doing it.
Okay. Yeah, we were just saying that first it looked from the literature that we should learn to distinguish, like to move away, because our original way, our vulgar way of defining different transcendentals was originally doing like this, right? And then we would add some weird stuff here inside, and this would qualify that the distinction, right? Like we would say, you can have minimal, intermediary, and maximal values. That's intuitionistic. If you only have a minimal and a maximal, that's Boolean. If you have like 3 values, and we used to write like very vulgarly like this, where it's like minimal, maximal, and something, a third weird thing, a third secret thing, then it would be paraconsistent, right? Then we moved from this to a more topological thing, which I think is the second thing we've been using, which is to refer to the to a topological interpretation with open, closed, and clopen, right? Which is what we used in the social atoms text. That was our go-to kind of distinction. And more recently, the thing that, going back to the literature, it's clear that at least the first option we were exploring is that the ID function is always the same. It's taking stuff from A to T, and we just need to learn to present the algebras of T properly. So TA would be something exactly as the Mortensen text says here, right? We should say TA is a distributed lattice with a maximal minimal element and a specific complement operator, right? That's what would distinguish it. So we would have like this, and this, and then you would add here this complement weird thing. And it looks like every one of the three algebras, right? The first three parts here, it's a distributive lattice with a maximal and a minimal. That part is the same for the three of them, in fact, right? And it's this operator here that we're using now to distinguish. In the case, it would be like, right, the classical negation and an intuitionistic negation here.
Yeah, I'm a bit rusty on, but as I remember in the, like, it's fine to define like both operators. Like you can, in the Bi-Heiting algebra, you can have like this lattice where you can define both negations such that they kind of exist in the same lattice. I don't know what happens to, maybe you cannot get like, I guess then it depends on like, you can interpret the logics using both one complement and the normal one, and then you get the two sort of logics specifying, but you can still think of the Bi-Heiting thing that they live in the same lattice where you have two operators which like leads you to different logics, right? And there's all like, you can even like make these two negations interact and get more stuff. One question I have is like the identity function. Is there like a classical name in like in the mathematical literature? Like, or is it like like where does it come from in the literature?
I think it's Goldblatt has something very similar, doesn't he, Dennis?
Yeah, it's not called the identity, it's called the it's basically equality, right? It's the way it's written is like equals and then as a subscript the degree of equivalence. So normally when two things are equal, it's either equal or not equal, right? True or false. But in these when we use an algebra, we interpret that equality in terms of a piece of a space, right? A sub region of a space.
Yeah, I'm trying to find here in the Goldblatt text where this is. I remember it was very soothing and a relief to find out that it was actually written somewhere.
Isn't it just the sub-object classifier for intuitionistic values, right? Because it's taking two things, or is that not quite the same?
No, it's taking two elements of a set and telling you how equivalent they are. And the sub-object classifier, that comes later because the complete hiding algebra set is a different way of formalizing the notion of a sheaf. And when you have to show that the complete hiding algebra set can be turned into a sheaf. And once you turn into a sheaf, you can then take sub-objects in a topos as usual. But actually the CHA set is a totally different formalism. It just happens to be equivalent on some level. as a sheaf. But as far as I understand, the CHA sets, I'm not sure there's a subobject thing. Well, I can
Okay,
look for
so
that.
it's they're equivalent on like a higher level, but they don't necessarily translate one into the other.
Yeah, this is where the whole tripos thing I was mentioning in the chat. There's this idea of a tripos that connects the two concepts of the hiding algebra sets and sheaf toposes.
Because that's something you brought up in the chat, Dennis, it seems important at this point, which is that, you know, we need to be careful to distinguish between like the world of sets and the world of algebras. Because in the world of sets and topology, at a certain level, closed and open, which seems to be the problem right now, are trivial, right? You can always describe one in terms of the other. But at the level of the logic and the algebras, they become non-trivial differences. And I think part of the question we're trying to answer before you came in is like, what level do those like trivial differences start to become non-trivial, and like where are we exactly in that between like the set and the topology and the logic? Like how do we get that non-trivial difference? And that's where the external internal thing came up, which is the comment Mortensen makes about externality seems to indicate like that's why it's trivial, right? It's external, it's just a relabeling. We're talking about the same thing with different labels, but in order to make our modal logic work, we need A and C to be like different. And so that seems to be the heart.
Yeah, I would push the, yeah, I agree, but I would push the issue that you and Renzo mentioned, and that Dennis also mentioned, which is, I think that we have two options. Let's say we understand what I don't think we already do, but let's say we understand this different, the intuitionistic topos and the paraconsistent topos. Like I have a hard time even understanding like some basic properties, but let's say we understand them. We have two options, it seems, right? Option one is to say we will have some weird, I would even say like, right, worldly transcendental, and you have our domain, and we're gonna have like the function, the mappings will be the modes, right? Which is something Dennis said, like, no, this is not what we want. But then by the end of the conversation, he was like, yeah, maybe that's what we want. So that's one thing. And the other thing is to say that you have your multiple and you have always the same ID function. So whatever axioms are valid for the ID function, they are fixed, but they map to different transcendental. And the structure, the differences are on the algebras of these transcendentals. They don't have the obligation to be subsumable under one common structure. Like the first thing that comes to my mind why the option 2 would be better than the first is just because doesn't the first option imply that when one of these functions maps to a maximal value on the world transcendental, it should be maximal for any one of the three layers, whereas we accept by the multiplicity principle that you can be minimal on one layer and maximal on the other, or much higher on the other. So is there any congruence of values that you're obliged to accept if you take this kind of unified perspective? But since I'm not sure yet on how we distinguish these things, I wonder if this question here is the one we should address first.
Yeah,
versus
just a question there. Because couldn't you have like a more, like you could even have, they in principle TATB, the functions map to different maximums, and then you have the special case where they match, and then they sort of like, they have some sort of like coherence, right? So meaning you could have the
I
case
see,
that
yeah.
that the TATBTC, they sort of like align in such a way that you can talk about it in like as it being a single.
Yeah, like as if there is like a intersecting kind of smaller structure than the tree that is like coherent for all the values somehow.
Yeah, like maybe
think
if they
that's-
align, like the alignment thing could have something to do with that.
Yeah, I guess that I think that all these issues have to do, but all
What's
those
the-
ideas need to be compatible with whatever commitments we make by making this decision. So, but this is before this, I think that there is this thing that is not clear yet, and it's an interior problem, which is like this is what we were struggling now, which is simpler, right? Like, okay, this is implication in intuitionism, this is negation, this is the complement operator. Are these the correct complement notions, right? And then dual in this weak sense that we were talking about. Apparently, it's too extrinsic to be considered by everyone canonically the dual of those things, but regardless of that, right? So how do we write the basic operations? That was already an issue, right? And then there are two issues that follow further that I would just add. Just take this whole thing here and bring it down. There is the two issues that follow that we still haven't really sorted out. And I think that when I was talking to Renzo, it became a bit clear that this is not very clear yet, which is we know that there is like for intuitionists, like if you open like the elementary topos definition, you get one of the crucial things is that you have finite limits, right? And infinite co-limits. And here, then you should have the inverse. Infinite limits. Finite co-limits. And then there are some things that we associated because in the topology text, they make it to be characteristics of these two things, which is somehow this is connected to the idea of a sort of implication of incompleteness and consistency. And here is associated with the idea of completeness and inconsistency. Right, so somewhere between the definition of complements, the inversion of limits and co-limits, we should be able to understand why these different systemic properties follow, right? And then there is a third fact, which is, I would even put it outside of the gray area, which is also a subtle thing, because when I was talking to Renzo about this, he made an intuitive connection that for me, I said, fuck, it's much more intuitive. But then when you try to work it out, you see that we want to push the inverse idea, which is that value is defined on an envelope, right? It works by making coherence the way that you envelope things, whereas, so it's an upper movement of synthesis, whereas gifts, they go to the common ground between two things, the conjunction between two things, right? So it's a weird kind of connection between value and union, and between gift and intersection.
Yeah, at the beginning we were almost convinced by the opposite, right? That
Yeah. But like the intuitive but apparently wrong version is, yeah, value is clearly about intersection, because when you have two things, you ask, what do they have in common? And they have value in common. But in fact, if you take a thing and whatever it is, and another thing and whatever it is, there is not one atom of value in them. So it's not a part of them that is the same, right? It's the price that connects them. So the part that connects them is not in them, right? Whereas the intuitive thing would be to say, well, when we exchange gifts, it's a matter of union because things are different, but we are part of the same community. They're included in something. But when you look at it, in fact, it's the inverse. Like it's the concrete thing that they are that is relevant, right? Even if they're not the same. So it's there's still something kind of
I
sociologically.
wonder if we can tie that somehow to the difference between finite and infinite in each one of those. That something about the
Yeah.
finitude is in appearance, and the infinite, precisely because it's more scalar, kind of is like also concealed in a weird way, and you have to kind of abstract to see it more.
Yeah, because then that's what we started thinking about, like the fact that the attention, the social attention, goes to intersections in a space that you have infinite limits, and it goes to unions in a place where you have infinite co-limits. How do these things connect, and why is the direction where you have infinite things the direction where the issue appears? So there is, I think that this is the core problem to understand exactly how do we derive these things, these different transcendentals, from this inversion, which seems relevant, right? And we need to have a very clear intuition of how this connects to this, to the opposition between these two operators.
I think, isn't it like the first thing a problem is like algebra? The one on union intersection is topology. It's like how, because it's about like finite and infinite unions and intersections, and the mid one is like model theory, right? It's like metalogic. It's something else. So it's,
yeah, we've read a bunch of texts, and now we have problems in all the disciplines that those texts touch upon.
because I think the first problem is like how do we understand the algebraic properties that relates to these three logics. The last one is like how you interpret the sort of like topological properties that follow once you interpret these logics in like topological spaces, because they are based on like this axioms of finite and infinite things. And then you have this metalogical or like model theoretic properties of incompleteness and inconsistency, which is like it lives in like a still another like level of discussion.
I mean, it makes, I mean, I'm not sure if I'm stretching, but I find it good that the way we work is by navigating between these things, because it sounds to me more on the categorical spirit to be a bit kind of, slutty with your field connections, like your interdisciplinarity between logic, algebra, and topology. I mean, it should be, because it's kind of in that weird ballpark of connections, right? So I find it interesting that something that it's clearly extrinsic to people who are specifically in the logic department, who sounds like they call it trivial. In the topology definitions of closed and open, it also sounds trivial. It's only in the relative point of view that it doesn't. Like the guy who wrote the Ken Baskent text, the one on semantics and topology, like he's in between fields, semantics and topology. And then he doesn't consider it trivial. He says one thing has this property, another thing has that property, right? So it only looks non-trivial in a relative kind of way.
Mm-hmm.
So I don't know if that's a hint of something, but that sounds interesting. And it does seem to me that every time I want to clarify these things for myself, if I try to be like mixed field, it becomes clear. Like I think, oh, well, if you have like two open sets with no clear boundary, you're not going to take, like if you want to settle something, you're not going to take the conjunction here. You're going to establish the boundary. It won't come from finding a point. It will come from how you synthesize this upwards, right? Like if you want to create a boundary here, I feel like you're going to go here and delimit something up. Whereas when you have the closed stuff here, I feel like if you want to find a point of synthesis, you already have this point here at the frontier, right? So that kind of gives me this general feel of like a downward conjunctive thing versus an upward, union thing, but yeah, it's just that I find it a kind of funny little fact that it sounds like it gains weight and clarity and like a gravity of what's up and what's down, what's trivial, what's not when you add another field. But yeah, I have the impression that if you just look at the lattice and you just look at these two definitions, and we were already having trouble with that, and you just say, yeah, so the pseudo complement of P is going to be everything that doesn't have the intersection of everything that doesn't have a union with it. You're going to get like a different kind of thing, whatever, something like this, I don't know. And then you're going to see that these two things, they're just inverted. I think that's kind of what's the reason why it doesn't look like a different operator. So it does look like if you just stick to the algebra, people say, yeah, but they are very similar. You just define two operators on inverse features, and then you get something different. But I still don't understand this well enough to. So I would say, like, fully understanding this, in my opinion, is a first thing. So you have the Mortensen text for this. I think it's the only. I would say the Mortensen, and the Tarski ones.
Yeah,
perhaps,
I mean,
because they deal straight with the algebra.
if we want to get intuition, like the best place I got intuition was from, I think, a link Dennis sent some, I don't remember when, but it was like the toy example on graphs. You can very clearly define these two operators, and you can play like how you negate stuff in the graph and you get like different subgraphs, and then you can see how differently like this two different definitions of complement gets you in different places. Like you get to see why like there's a border in one case, there isn't in the other. But I think there it's defined with using closures. Like you do like complements and closures, which is like an alternative way to define, which is not like lattice based. So I don't know, like there's a limit to how much intuition, but at least you're not in the setting of the lattice, you're in the setting of like graphs but it's nice to get a hold on why, like in practice, you get like you obtain different stuff from these operators.
Yeah, I think that the Tarski text, it's Tarski and McKinsey, it might be the good one because it starts with the topology, and they define topology as closed set topology, and then they take an algebra and they construct the algebra step by step, and then they show the operator will be what they call the closure algebra, which is like what turns out being the Breuer one. The closure algebra is paraconsistent, and they give a bunch of definitions. I haven't studied the text properly. That's one, and then they have a second one called on closed elements in closure algebras, which is a continuation, and then they define the Breuer algebra. Breuer, the first section of the text called Breuer and algebras and their relation to closure algebras, and I think that's it's all on the lattice. So it's definition on the lattice. With a minimal, a maximal, then they define the negation as the Breuer and complement, and they give a definition of how it works. It's slightly different notation. I get lost in it, but I have the impression that for this problem here of understanding exactly how these two are different, that's probably where I think we could start. Then if this makes sense, I think that this is the second problem, this big issue here, because then it's partially on the mathematics, partially on our side of making sure our basic intuitions are met, right? And there is, let's say, a connection. Now, we had the algebra and the topology here. This is more algebraic. This would use probably the topology with the logic, right? So the two texts, I forgot the name of the author. One is by that Baskent guy. The other is another text John sent as well.
Oh, the apology via higher order intuitionistic.
It's not Vickers, right?
Escardo. Yeah,
Yeah,
it's
Escardo.
Bashkent and Escardo are the two I sent.
And even the text by the Belgian fellows, I forget, the conciliation text, it already goes a bit in that direction, because they do they are interested in the global features of these things, right? How they change. So Lambert and Haskell.
The contradiction to conciliation one.
Yeah. And then I'd say that this third thing here, right, which is already a bigger matter, like we already know how the transcendentals work, we know how to separate them, and we want to know if we should keep them separate, option 2, if we should keep them, try to find out like this bi-heighting thing, and if that's our natural environment for worlds or not. Like, I'd say that that's kind of the big third problem, which we never thought about until recently, right? And then there's I think Roge, how is it written? It's like this, right?
Yeah.
The Haskell text ends with this issue as well. If you open the conciliations text, it has the weirdest diagram at the end you've ever seen. Let me see if I can find it here. Right, it ends with this weird thing here that I remember Dennis and I were. No, Dennis, this is not the link for the STP. There's a separate one. We should probably close. Yeah, but this thing here. Just open it. Guys.
Are we putting the Estrada Gonzalez texts with Mortensen or someplace else? Because he's kind of like building on Mortensen.
Yeah, it's a good question.
I haven't even got a chance to look at those, so I have no clue how they all fit together.
Yeah, I wonder what you guys think of it. Yeah, so this is the crazy diagram that they add.
This is a side note. I do think if people have like philosophy and basic logic backgrounds coming in, I do think the Raziak's a really good text to recommend to folks.
But if you see this thing here, you see that they add the bi-heighting algebra here, right? As the right. So God knows what that means. But I think that these are the main three things, just from the formal point of view. Like I don't know, my strategy would be to understand the first one before we move to the others, but they're all complementary, I guess.
I think that's a really good mapping of the different levels of the problem.
Yeah, the thing that bothers me the most is the second thing, because ultimately, like every time we've had a good intuition that is not exactly purely mathematical, but like a conviction that we've nailed something for like concept formal connection, it just gives me a lot of strength to pursue it formally, knowing that that's a good direction. When I'm uncertain about how it goes together, it's much harder to find a way to to pick where to search and things like that. So personally, I like to get a stronger feel for that issue of, okay, how is this topology we already decided on that does make sense when we use examples and so on, how does it connect with the logic, and then perhaps clarify the algebraic side as we move, like that's how I'm not sure.
I mean, that seems
Yeah.
right. That was McLean's whole slogan, right? It was an algebra as a combination of geometry and logic. So seems like the right direction. I have no clue how to do those things, but that's what he said, and he's pretty good at that stuff. So
Yeah, my only thing is I was thinking we haven't really pursued this enough, but like thinking of the set A, the one that the identity map goes to or comes from, that set can be composed of is made up of sentences, logical sentences, right? Because all the literature it's when we talk about logic, we're talking about logical like symbols strung together to form sentences, and then evaluating them as to their truth value. So that's very different from what we've been using it as, right? If we're talking about like gift or value commodities, it's not exactly clear how that maps to like logical sentences, right? And Badiou does this thing with like talking about them in terms of intensity of appearance, but in the literature they don't regard anything with intensity of appearance. They call it, the truth value of something. So that's a bridge we have to cross to.
I agree. Okay, talking about bridges to cross, we can bring that to the next meeting because it's all about crossing bridges anyway.
oh yeah, but we're there, aren't we? To the next meeting.
Yeah, yeah, exactly. I just need to open the other room. So I'll
Alright.
just close this one and open it.
This was a good
That's it.
talk though, guys.
Yeah.
Thanks
Yeah, it was.
for really helped work through it.